Okay, so let's go ahead and take a look at this next lesson. So this next lesson, the only reason why we're going to do this lesson is because there's something that College Board does on the actual AP test, or at least they've done it for the past couple of years. And I really want you guys to do well on this situation, which is if you see the situation where what you notice is that, look at this equation. They give you what's called a differential equation, meaning they give you the equation of the derivative. But what do you notice about it? T is your independent variable. Where is T? So they have eliminated the independent variable from the actual equation. So when you look at the equation, it's different because all you have is you have a derivative equation with the dependent variable in there. You rarely see that, and so it's really important that we do some problems that are actually, former AP questions, because I don't want you guys to get confused when they remove the independent variable. Okay, and I've seen it happen the last couple of years. We did this section last year, and still people got confused when we removed the independent variable. And so we're just going to keep practicing these. Okay, so in this free response question, at the beginning of 2010, a landfill contained 14 tons of solid waste. The increasing function W models the total amount of waste stored in the landfill. Planners estimate that W will satisfy this differential equation for the next 20 years. W is measured in tons, and T is measured in, not years, since the start of 2010. Use the equation of the tangent line to approximate the solid waste the landfill contains after the first 3 months. Okay, which is when T is equal to 1/4. Okay, so I want to write the equation of the tangent line. What do I need? To write the equation of the tangent line, I need the derivative evaluated at a coordinate point. So the coordinate point that I was given was 0, 1,400 tons, because that's where we start off with. So dW dt is 1/25. My W is what I'm looking for, so that's 1,400 that goes in there, and then minus 300. And so I get 44. So to write the equation on the tangent line, not y. W, because that's my dependent variable, minus 1,400 is equal to 44 times t minus 0. So W is equal to 44t plus 1,400. So now I want to know what happens when time is equal to 1/4. So W of 1/4 is approximately equal to, or we could say is equal to 44 times 1/4 plus 1,400. So we will get approximately 1,411 tons of solid waste. Okay, it's important for you to kind of think about whether or not you are creating or getting an answer that makes sense. Okay, so just be careful. Okay. So let's look at part B. Same thing above, but now find d squared W over dt squared, and use this to determine whether or not this is an underestimate or overestimate for your W of 1/4. So let me be clear about why we're doing this. So what they're testing you for is if I have my function be concave up, then my tangent line lies below the graph. So this makes this an underestimate. If I'm concave down, my tangent line lies above So concave down, tangent line lies above, and so this would be an over estimate. The tangent line would give you an over estimate of what the original function would be. Okay, so first let's find d squared w over dt squared. So d squared w over dt squared is equal to 1 over 25. Derivative of w, 1, dw dt. Derivative of 300, 0. So you get 1 over 25 dw dt. What is dw dt? This equation here. So you get 1 over 25 times 1 over 25 w minus 300. So this is 1 over 625 w minus, let's clean it up a little bit, w minus 300. This is d squared w over dt squared. Okay, so now we're going to at least be bigger than 1400, right? So w has to be greater than or equal to 1400 because that's what I started off with, okay? So if w is something bigger than 1400, this entire equation is going to yield something that's bigger than 0. So something that's bigger than 0 times 1 over 625, which is also bigger than 0, means that d squared w over dt squared is bigger than 0. So w is concave up. Okay, so since d squared w over dt squared is bigger than 0, then w is concave up. So w of 1/4 being equal to or approximately equal to 1411 tons is an underestimate. Because remember, concave up means that the tangent line lies below, so that would have been an underestimate of the original function. Okay? And they love these, and the reason why they love these so much is because they can throw in separation of variables into this. So remember I told you when we did separation of variables before, and that is I am 90 to 95% sure you're going to see separation of variables somewhere on your free response test. And where they like to do it is by disguising what the equation actually looks like. And so I am looking at this part C here, and it's going to ask me to find the particular solution, W equals WT, to the differential equation that was given that W of 0 is equal to 1400. Finding the particular solution means to find the original equation. This is where it gets tricky because you have to separate the variables. So dW dt being equal to 1 over 25 W minus 300 means that I actually have to move my W minus 300 to the left-hand side. So this is 1 over W minus 300 is equal to 1 over 25 dt. Then you integrate both sides. It is really important. I know that sometimes you guys get, you think you have patterns down. This should be dW. You think you have patterns down and you think that you know without doing U substitution, and then you might be off by a negative sign somewhere. Because you should have done U substitution to know that you would have had a coefficient there somewhere. Okay, so just be careful. So I would let U be equal to W minus 300, so DU is equal to DW. So there's no worries here. 1 over U du is equal to 1 over 25 dt. So this is the land absolute value of u is equal to 1 over 25t plus c. I can resubstitute my u back in. So land of absolute value of w minus 300 is equal to 1 over 25t plus c. And again, just like I normally do, I would use my initial condition at this point. So my initial condition is w of 0 is equal to 1400. So ln of 1400 minus 300 is equal to 1 over 25 times 0 plus c. So my c is equal to the ln of 1100. Okay? And so I get the ln absolute value of w minus 300 is equal to 1 over 25t plus the ln of 1100. Okay, I need to isolate w. So remember that the base of ln is e. So e to the entire right side of the equation is equal to this absolute value. So e to the 1 over 25t plus the ln of 1100 is equal to the absolute value of w minus 300. Okay. Rules of exponents tell you that this addition symbol means multiplication, and I can separate them out. So e to the 1 over 25t times e to the ln of 1100 is equal to the absolute value of w minus 300. Now, this e to the ln of something is just the something. So this becomes e 1 over 25t times 1100 is equal to the absolute value of w minus 300. I'm still trying to isolate w, meaning w to the first power with no coefficient, with only the coefficient of 1 and nothing being added or subtracted to it. So that gives me 1100 e to the 1 over 25t is equal to the absolute value of w minus 300. Now, we look at, when we talk about dropping the absolute value bar, we look at the initial condition. But remember, your initial condition is 1400 goes in for w. So if I'm plugging in 1400 in for w, then that results in a positive value. So I can just drop the absolute value and get w minus 300. So now, by moving the 300 to the other side, w is equal to 300 plus 1100 e to the 1 over 25t. Okay, and let's be clear, it says it would satisfy, they said that this would satisfy for the next 20 years. So technically, the domain of this function is 0 is less than or equal to t, which is less than or equal to 20. Okay. I don't know if I don't think you would get marked off for not stating the domain, only because it didn't actually ask you for the domain. But if you can remember to put the domain of the function there, it would probably go a long way to making sure you don't lose any points. Okay? All right, and that is it for this lesson.